This is our machine at home with 3 different length tools. The distance from the tip of, we're going to call this one tool 1, this one tool 2, and this one tool 3. The distance from the tip of that tool at home to our part program 0 is going to be our height offset number 1. The distance from the tip of that end mill to the very same position on the part is height offset number 2. Do you see these two heights will be different? The tool lengths are different. Tool 3, same thing. Height offset number 3. Guys, the way I'm going to do this, I'm going to coach you on a hoss first, is I'm going to bring this tool from home, I'm going to bring it down and touch the top of that part. When I look up at my register on my machine, or what you guys are familiar with as a DRO, how does a DRO work? A digital readout? Right? But if I move, it registers movement, right? When I come down and I touch the top of that part, if I look at my, this is 0, machine 0, when I look at my machine register, it's going to tell me exactly how far I've come down, isn't it? It's going to give me a value. It's going to give me the inches I am away from machine home when I touch the top of that part. Let's say this distance on this one is minus 7 inches. This one would have to go farther, wouldn't it? Let's say it's minus 9 inches. This one would go less. We'll say it's minus 5 inches.
I thought your minus was past your 0 point of your part.
No, this is machine numbers. We're having to go minus to go to the top of the part from home. Is everybody with me? These are great questions, Mark. This is machine 0. We come down 7 inches to touch off tool number 1. I have a registry, an offset page in the mill that says tool 1, height offset, wear, diameter, wear. Tool 2, tool 3. Height offset for tool number 1 is minus 7 inches, isn't it? For tool 2 would be minus 9 inches. Tool 3 is minus 5 inches.
I got a question.
Yes.
Like, how would they have me do it? They just take it out and measure it? Is that measuring the same thing from the tip of the tool to the top of the spindle?
No, different method. Different method.
So you have to program different?
Yes.
Okay.
Yes, could be programmed differently. When you're doing a tool measurement, you're giving it an actual tool height. Then you would use your G54 to tell it where the top of the part is.
Yeah, because I go touch off and then I put the tool in.
Yes.
Okay.
And there's a little more math to your method, is there not?
Yeah.
Because you have to touch off and subtract a tool length, and then figure out the tool nose, or what they call the spindle nose to the part program 0. Let's not go there just yet, because it's a little more difficult, a little harder to understand, grasp. We'll talk about what they are with this method, and then I'll show you some variations of those methods. Okay? Is everybody with me? How I'm just putting these these numbers, listing them underneath the H. Tool 1 is a center cutting tool, so it really doesn't require a diameter compensation amount. You can't adjust the size of a hole by telling it the drill is bigger or smaller, can you? Does that make sense to everybody? But tool number 2, that's a 1-inch end mill, so I could have that 1-inch diameter underneath the decomp of tool 2. And that's where I would call that in, and I'll explain cutter radius compensation later. This is just a list of values, keeping in mind that I pull these into my program. You guys all remember the G43H1? I'm calling in the value of the height offset for register T1. When I call up tool 2, I would have to call up H2 to get the length compensation amount for tool 2. Are you with me?
Do you have to put a diameter in?
Say again.
Do you have to put a diameter in?
If you're not using cutter comp, it won't matter. If you're using cutter comp, you have to tell it how much to comp. This is where you tell it how much to comp.